Hi, I'm Jimmy Chang, and we're here to talk about how to write quadratic functions in an equivalent form as the product of two linear functions. Now, as you know, a quadratic function is of the form ax squared plus bx plus c, where a is not equal to 0, and b and c are just numbers, constants, if you will. Now, in order for you to write any quadratic function as a product of two linear functions, it's best to see whether or not it's factorable, because that's really the most convenient way to do it. Now, for example, if you have f of x is equal to x squared minus 8x plus 15, you have to ask yourself this one question: can I write it in factorable form? Because if it is factorable, then I could write it as a product of two linear functions. So actually, in this case, it is. You have x squared breaks up to x and x, and then factors 15 that add to give you negative 8 is actually negative 3 and negative 5. So you have a product of two linear functions because x minus 3 and x minus 5 are both linear. Now, if you have another example where f of x is equal to x squared plus 4x plus 4, again, ask yourself, is this factorable? Because if it is, then you can write it just like that form again. And in this case, it looks like it is as well. X squared breaks up into x and x. Factors of 4 that add to give you 4 are 2 and 2. Signs are both positive. And in this case, you have, again, a product of two linear functions. And in this case, you can write it as x plus 2 squared because the parentheses do match. So in order for you to write a quadratic function as a product of two linear functions, you really have to ask yourself, is it factorable? Because if it is, you can write it like this. If not, then it's going to require a lot more work involved. So I'm Jimmy Chang, and that answers the question how to write a quadratic function in an equivalent form as the product of two linear functions.